Hi and welcome back to the breadboard. In this video we're going to be looking at how to build the table for the CNC Router project, starting with designs and going through to the actual build using some 3/4 inch 8x4 plywood. Using DS Mechanical, a free download from RS Components website, I designed the 5 by 5 table using 3/4 inch plywood sheets, starting from an 8x4 sheet, marking all of the cuts on a cut plan, and then following my design diagram, I proceeded to cut the plywood sheet down to the desired sizes, starting off with cutting the 3 feet off the end of the 8x4 sheet, and then taking the 2.5 feet wide sheets from the remaining larger piece to glue together to make the 5 by 5 base platform. Before cutting the 4-inch strips from the remaining 1.5 foot wide by 5 foot sections, I used the V-slot rails to actually confirm the straightest edges to use as a guide against my table saw guide in order to get the straightest cut. The one thing you can be sure of here is that the V-slot rails are going to be very, very straight, and if you look at the edge of the manufactured wood from the store, you'll see that one edge has writing on two, and this one is usually guaranteed to be very, very straight right from the get-go because it's factory cut. After that, I proceeded to cut the 4-inch strips off of the remaining 5 foot by 1.5 foot sheets of ply in order to use these for the underside rails that will become part of the pseudo torsion box that I was going to build to add an extreme amount of rigidity to the whole project. It is important to take note that while you're cutting the 4-inch strips, these need to all be exactly the same height so that when you start screwing any bottom pieces on to make it into a complete box, it is able to adhere to all of the top surfaces. If any of the edges are slightly lower, then of course they're not going to match, and you're going to have air gaps, and you're going to lose some of the rigidity of the box. But in if you set up the saw once, clamp the T-square on the saw blade, for the guide, and don't move it until you've done all of the 4-inch sections. Then you should be good to go. So using a tool called a biscuit joiner, this one is from Cable. What I'm going to do here is join the two 5 feet long by 2.5 feet wide panels to make one full 5 foot by 5 foot square panel. The biscuit cutter, what it does, you can see the blade poking out here, is it cuts a little semicircular slot in the edge of whatever wood you use it against. Here I'm doing a test cut in a 2x4 or a couple of 2x4s to make sure that the depth is set correctly and that the biscuit is going to fit into the slot properly. Here I'm cutting the second piece, and then I'm going to be putting them together. I forgot to set the depth to the right level, so I set it to suit the number 20 biscuit. Now I've got the two pieces cut. I will put them together with a biscuit, just dry, to make sure that they actually meet properly and are of the correct height. And by that I mean when you put the biscuits together like this, the top surfaces, because you cut from the same side of the wood, should actually meet up exactly. And the next thing is to go and mark at 6-inch centers, is what I used, across the two edges of the 2.5 foot by 5 foot sheets that are going to go together, and cut a biscuit on each one at the same position all the way across the width, and then glue it up, glue all the biscuits in, and put the glue all the way along the edge of the joint, and then glue the two pieces together using clamps and V-slot extrusions to hold everything nice and flat and tight together. Leave that overnight to dry, and then used a scraper and sander just to remove any residue glue that will have oozed out. This produces a nice, solid, and stable 5 foot by 5 foot panel ready to build the rest of the tabletop onto. Now, using the 5 foot long by 4-inch high pieces of plywood we cut earlier, we start laying them out around the perimeter of the tabletop, gluing and clamping as we go. Now, I used two of the 5 foot ones first to do opposite ends, going across the join of the 2.5 feet pieces to add an extra bit of strength. And then I used the 80-20 extrusions and to keep the table absolutely flat and to help keep the glue up nice and solid. And then also used clamps, and remembering to use a T-square to make sure that the vertical pieces are at right angles to the main table surface. Now, all of our 5-foot lengths of 4-inch wide ply, they're all exactly the same length right now because that's the way we cut them. And whilst by design we could take off 1.5 inches and just drop them in there, it is prudent to actually remeasure the gap between the two pieces that you've just glued on, because wood, it's variable, it expands and shrinks, and nothing is exactly the way it would be if you were cutting, say, metal or something like that. So remeasure the gap once you've glued your end pieces on that you're going to be filling with the next piece, and then cut it to fit that gap exactly. This way you're going to have the maximum contact with the mating surfaces, and that's going to give you a lot more rigidity and enable it to keep itself nice with right angles and a solid construction. So for all of the following pieces that we're actually going to create, even though dimensionally we know what they should be, measure what it's going to go into first and cut to that measurement, not to the design itself. If you're in a position where you're going to cut multiple pieces at one time from different areas of the table, then it also pays to mark them with a letter or a number or something so you know which piece goes back to which location to ensure you get the right sizes. Now, following the same procedure of putting down ampoule glue, clamping, making sure things are square and at right angles, and also using some of the aluminum extrusions on the underside of the work surface, we clamp the inner pieces, again, as I said, measuring to make sure that they fit, and putting, like you can see here, a clamp underneath with a piece of extrusion to keep the bottom absolutely flat. And then I've got a piece here that's the 5.5-inch wide piece, it's just sitting there for size. But then we clamp the other end and do the other side of the table. Now, because my clamps don't have the reach to get in 5 inches from each side of the table to glue it up and clamp it properly, I use some of the aluminum extrusions to reach out across the table and then clamp on those, providing the central clamping pressure needed to hold those inner 5-foot long sections down firmly on the desktop. Sometimes it also helps just to scribble on your piece of wood that nobody's going to see exactly what you're trying to build, just so you don't forget when you're beavering away and not looking at the actual plans. I then proceeded to do the same for the inner two sections here. I haven't put the clamps on them yet. I allowed the first two to dry, and while I still had the clamps on, I put these two pieces across, and what I'm about to do is actually move the clamps from the old position and put them across the new ones. I just didn't take any additional pictures at that time. Now, again, apologies, but I forgot to take a few pictures while I was doing this bit. But basically, you can see all of the 4-inch by 4-inch pieces that have been cut and fitted into the two different troughs. There's two different ends of the box. This is showing one end. I also cut a 1-inch hole all the way through, including on the outer perimeter, so that it allows me to feed in cables or conduit and cables later if I so desire, and I did that in both directions. Obviously, the wider of these blocks that are going in, they're 14-inch wide as opposed to the smaller ones that are going from bottom left to top right, which are only 4-inch wide. But either way, they're all cut from the 4-inch wide strips of 5-foot long pieces that we cut earlier, and they were measured to cut to the measurement that we took for each position they were going into, just in case there was any slight curving of the boards, the 5-foot long by 4-inch high ones that we had done earlier. So now that we've got the holes cut and we have all of the intersecting pieces for our pseudo torsion box, in case you're wondering, a full torsion box would have additional cross members on the innermost section of the box that you can see here that's not filled in with anything. I've left it out because I want to have that actually sit over the table that's sitting underneath it, so it actually won't add to any height except for the 3/4 inch of the main top sheet. This still gives a lot of rigidity, which I'll show later with a bit of a video at the end of this talk through the picture section. But anyway, in the meantime, all of the side pieces have been cut, fitted, glued, brad nailed, clamped, allowed to dry overnight, and then I've started to, as you can see here, put the top section, or it's actually going to end up being the bottom section of a box to fully encase it and add even more rigidity to both the front and rear sections. And again, I'm using the 80-20 V-slot extrusions to spread the load right across and ensure that everything is kept absolutely as flat as possible. That way, once the glue's dried, it's not going to move away from that position very easily without breaking. Once I'd actually allowed all of this to glue up and dry, I actually found that the resulting table was extremely rigid already, and so therefore I decided not to box in the left and right hand sections that you still see exposed in this picture, because it wasn't going to add any significant rigidity to the overall product. Now, if during testing I find that it is still flexing or a little bit of excessive vibration or something, then I will go back and actually seal in those two sides as well. But the center section will still remain empty anyway. Anyway, that's pretty much it as far as the basic build's concerned. Here's a bit of video that I recorded out in the garage as well using my camera, little handheld one, so I apologize for the video quality, just to go through the final stages and providing a few additional comments.
As you can see here now, we've got the whole box section of the table built. The pieces like here, right, they've got the strapping inside as well, so you've got the cross members for part of the torsion box. Now, a torsion box normally would have the entire surface on both the top and bottom covered, but the main structural elements are things like these cross members. These are glued, and I've also pinned them with brad nails through the sides as well, but they're glued on all three sides of these. So you've got two here, two over there, plus you've got the full long beams over the back and on this side coming right across, so that everything is glued right down, so there's no movement going to be happening. And then these two top pieces here are also glued and pinned in place, but primarily the pins are just to hold it while the glue sets, which is now done. And you've got the one at the back there. And the thing about the torsion boxes now is that I can try and lift this at one side and it won't twist. Before, it was actually twisting when I tried to lift this, and I'm trying to do this with one hand here, but now it will not twist because of all these extra bracing. And one of the things that you'll see with all of the series of still pictures that I've taken is that I've used the 80-by-20 extrusions, which are really straight and strong, as a clamping mechanism to ensure that all of the edges are kept perfectly straight when I've clamped them, so that the plywood surface is perfectly flat, so that now theoretically when I turn this over, aside from the fact that the table that it's sitting on is slightly uneven, you can see it rocking just a little here. That's not the tabletop, that's the table that it's actually sitting on underneath there. So I'll have to shim it a little bit just to take that rock out of it, but now this thing should be perfectly solid and ready to start taking the router on top. Now, in case you're wondering, this blue pipe here is just some electrical conduit, plastic electrical conduit. I was debating whether to run it right from the beginning. I haven't cut it yet, so I've got 10-foot length here, so I can cut it in half, and it could make it easy to run some wires from the front to the back of the CNC table, but keeping them underneath and out of the way. And I have them going in this direction as well, under here. I'd have to use some kind of rod to feed it through or something like that, which is easy enough. I've done that before. So I can, in either direction, on all four sides, I'm able to run wires inside the table. And things like E-stops, what I'll probably do is put like an E-stop here or something, and the cables can come through the table, or even put the E-stop right over the top of the hole on each side, because this is basically the front. I just have to flip it over. So having an E-stop on each end here would probably be the thing to do. I have two of them. And then the wires can run inside to wherever the control panel is, and ultimately I'm going to put the control panel on that back wall I've got some studs there. I've just got to put a big sheet of plywood, which I've got sitting over there. So I'm just going to put it up, got to remove a couple of nails to make room for it, and just lay it across there so that I've got something to screw everything onto. And then this will be here. Right now it's very cold out here. It's 0 degrees. We've actually just woke up this morning with snow on the ground. So yeah, I'm not going to be able to work out here much longer without putting some kind of heat in the garage. But it's not insulated, so I wanted to get this box built so that I can start building the CNC on top of it before it got too cold, because the glue won't set otherwise. That's all done now. Yesterday it was up at about 6-8 degrees, and the glue will work from anything from 5 and above, so it's all nicely set. I've checked it. And actually the last few joints where it got colder, I used polyurethane glue, which has a lower set temperature. So yeah, that's pretty much it. Now we just need to flip this over, and then we have the nice stable surface now to build the CNC on. So as I say, I did a lot of the videoing, or the pictures. I've taken still pictures because I didn't want to get my camera, my main video camera, out in the cold in the workshop and getting it covered in dust and everything else. So I just took still pictures with my Panasonic waterproof, dustproof kind of still camera, which is actually what I'm doing this video bit on as well. It's just not going to be as good a quality. So anyway, that's the table, 5 feet by 5 feet. Well, yeah, and we're going to do a 600 millimeter, sorry, 1.5 meter by 1.5 meter CNC. We may have to tweak it just a little bit to get it to fit properly, but by the looks of it, it's going to be just fine. And if I grab one of the 8-foot lengths, sorry, 80 by 20s, if I just grab one of the 80 by 20s and just lay it on the top here, you'll see that it's actually just a tad short, which is fine, because this is going to sit on top of a 60-20, so it's going to be sitting about that high. Alright, and you can see here, because this table is upside down, it's actually 5 inches or so higher than I want it to be. That's one of the reasons why I wanted to leave this hole in the middle, so that it actually sinks over the top of this table, rather than sitting on top of this table. I've already taken the top off the table from the old table. It used to be a router base, to make room for this, but the height here, I'm not like 6 foot odd tall, so I didn't want to make this an extra 5 inches taller. So I've actually left the middle so that when I flip it over, it's actually going to sit over, like curtain around the table legs. So it'll actually be, the top of the table will be at this height down here, not at this height, which would be much easier. So that this will be basically, by the time you've laid everything out, this height here would probably be about where the top of this rail is going to be anyway, because you've got a 60-40, will be a little bit lower. But it'll keep it at a manageable height. Anyway, I guess I'll go see if I can find some help and get this table flipped over, and then we'll lay out some of the extrusions to see what it looks like. Give you a little bit of a rough idea of the size of it. I've just laid out the 1.5 meter lengths of extrusion on the table, basically the way they would be. So you've got your 80-20s, your gantry, which is laid across there just with a green tape on it right now. That's made up of two 60-20s with a 40-20 behind it, giving extra support. And then you've got your 80-20 on each end that your gantry is going to run along. And then these two front and rear pieces are just to keep the gantry up off the table, so that the wheels, because they're going to go underneath as well, have plenty of room to run. So there are some options to lower it a little bit. I guess if there's enough space, I could drop the 80-20 here down a little bit. We'll have to see. The two 60-20s in the middle that are a little bit crooked right now, they're actually going to be for bracing across the middle of the table, and then we'll put the spoil board on the top of there. But what's going to happen, but I need to cut those. Right now they're just sitting in, they obviously the same length as the 80-20s at the side here, so they're not going to fit in there straight until I trim them down a bit. But what I'll do is I'll measure that and make sure I cut it accurately before trying to bolt everything up. But I'll have the outer frame screwed together and squared first, so that I can measure that distance in the middle. But as you can see, everything sits nice and flat. I was just looking across the front there. I don't see any air gaps on the bottom of this, right across the length. on either end of it, and I had one of these down before on this run, and it was pretty good there as well. So I'm happy with that, and as I say, it's as solid as it needs to be for this. And as you can see, we'll be able to put a 4 foot by 4 foot piece of work in the middle there and have quite a lot of height, because my Z-axis is going to be about 12 inches. So we have plenty of height to get anything really cutting out and everything on this tabletop. So that'll be good. Next thing is we'll start assembling the extrusions and getting some of the electronics looked at. But we're going to go through some of the theory and things of the electronics as well. So it won't be out here right away, and it's getting rapidly colder over the next few weeks. So I want to get a few things done out here before it gets too cold. Don't want to be sticking to the aluminum when it goes sub-zero in about a few weeks' time. But anyway, it's good. The computer that I'm going to have that's running this is actually good to go all the way down to minus 40 degrees centigrade. Most of the motors and everything else will, the operating specs for most of the parts I have go to at least minus 10 degrees or so. We'll have a look at those as we go through the electronic videos. So should be able to do this for part of the winter anyway. I've got a little heater, it's just sitting over there at the moment, that I could use just to take the chill off of the air in the garage here, as long as I keep all the doors shut. Should be good. And so yeah, I've got to make some more cleaning up in the garage because it's still a bit of a mess. I had to make the space for this, and I've got to get rid of a few things and get a few more things out into the recycle, so that I have plenty of maneuvering room. And of course, as I said, I've got to get that sheet of plywood up on the wall here. Probably have to cut it slightly shorter though, because I don't think I have enough length for 8 feet there. It's not far off, but I don't think it's quite enough. So that's a quick cut of that to get that done, and then we'll be set. Anyway, that's it for now. That's the table built. So next thing, as I say, electronics and extrusions.